Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about relations and functions. Okay, let's define what a relation is. A relation is just a pairing of inputs and outputs. So I have some input, I put in something, I get some output. So the relation is just that relationship between the input and the output. I go to a soda machine, I put in some money, and I get a soda out. So that pairing of input, doing something, and then getting something on the back end as a result, that's the relation. The set of inputs is called the domain. So typically the domain in math is going to be the inputs or x values of the relationship. So we have our xy coordinate plane, as you can see in the graph at the bottom of the plane, or bottom of the page. And our relation is 3, 4, and 2, 2. Those are 2 points. Those are 2 relations. The input would be the x value, or the 3 and the 2. And the output would be the range, or the 4 and the 2. So relations can be represented in 4 different ways. The first is ordered pairs. So in the example that I gave to you before, the ordered pair would be 3 and 4, and then in 2 and 2. So those are the two relations based on an ordered pair. The second would be a table. A table just sets up the x and y values. So x, I have the input of 3, output of 4. And for the y, or the x, the second relation, I have an input of 2 and an output of 2. The third is a graph, which we talked about. I have 2 points, 2, 2, and 3, 4. Those are both relations at both points. And also a mapping diagram. I can have an input column and an output column. So my input is 3, my output is 4, my input is 2, my output is 2. So 4 different ways that you can represent relations. Typically, we'll represent relations in either ordered pairs or as part of a graph in this class. All right, a function is a relation for which each input has exactly one unique output. Okay, so what does that mean? That means if I have a value 3, then it only has one unique output. So I can say 3, 2 and 4, 3 is a function. Those 2 points would constitute a function because I only have one output, one unique output, 2, for every input, 3 and 4. However, if I had something like this where I had 3, 3 and 3, 4, then I have an input, but I don't have a unique output. So every time I put in 3, well, I might get a 3 out, or I might get a 4 out. So this is not considered a function. If there are 2 different y values for the same x value, then it is not a function. Now, I could have the same output for different inputs. So what would be an example of that? Well, let's say that I have 4 as my output for both 2 and for 3. So I put in 2, I get out 4. I put in 3, I get out 4. Is this a function? It is, because I have exactly one unique output, which is 4, even though it's the same, for the different inputs. Okay, so if there's the same y for different x's, then it's a function. But if it's the same or different y's for the same x, then it is not a function. So let's take a look at some examples. I have the first example, 3, 2, 4, 2, 5, 2, and 6, 2. So are these relations represent a function? Well, do I have exactly one unique output for every input? I have 3, 2, 4, 2, 5, 2, and 6, 2. Now the outputs are all the same, but those outputs are all unique to a given input. I don't have 3, 2, and 3, 3, which would give me 2 different outputs for the same input. So this represents a function. Okay, second example. I put in 3, I get out 2. Put in 3, I get out 2. Put in 5, I put out 3. Put in 6, I put out 3. Now I have 2 different relations that are the same, but they both have the same input and output. So that's okay. 5 and 3, I have the different inputs but the same output. That's okay. So this is considered a function. My third example, I have 3, 2, relations 3, 2, 4, 3, 5, 4, and 3, 3. Now this is not going to be a function because I don't have a unique output for a given input. All right, so for 3, 2, and 3, 3, I have two separate outputs, 2 and 3, for the same input. So this is not a function. All right, now the vertical line test is a great way to determine whether a function is a function. The vertical line test says that if you can draw any vertical line through the graph and it only touches one point on the graph, then the relation is a function, or the function is a function. Okay, so in this case, I draw my vertical line test. I can see that regardless of where I put my vertical line, that it's only going to go through one point on the graph. So I say that this is a function. If I try that on the right-hand side, I see that if I draw my vertical line, my line ends up going through 2 points on the graph. So this is not a function. So the vertical line test says if I can draw a line through the graph at any point or any vertical line and only touch one point on the graph in all cases, then it is a function. If it touches 2 points in any part of the graph at any time, then it will not be a function. As we talk about the basics of relations and functions, we need to talk about also equations in two variables. And simply, a function with two variables is called an equation in two variables. So an example might be x plus y is equal to 5. Now, I would rewrite that as y is equal to negative x plus 5 for this reason. When I graph y is equal to negative x plus 5, my independent variable is going to be the input variable, or the x value. The output variable is going to depend on the the output variable is going to depend on the value that goes into the x. So y will be dependent on the input. So what matters is what I put in for x that will provide a result for y. So input variable, again, is the independent variable. It stands alone. The output variable is the value that depends on the independent variable. A solution of an equation in two variables is an ordered pair that makes the equation true. So I'm going to take my example, my equation in two variables, y is equal to negative x plus 5. And I'm going to say, I have an ordered pair, 5, 0. Does that make the equation true? Well, if I plug in 5 for x, I get negative 5 plus 5, that equals 0, and my output is 0. So that solution, that ordered pair, makes the equation true. If I put in 3 for x, I have negative 3 plus 5 is equal to 2. 3, 2 is an ordered pair that makes the equation true. What about 4, 4? If I put in 4 for x, I have negative 4 plus 5 leaves me with just plus 1, and that's not equal to 4. So 4, 4 is not a solution. Now there are different ways to write equations in two variables, and we're going to talk about several of them through the next couple of chapters. There are two that I want to highlight right now. And one that I want to highlight, and one is the slope-intercept form. And the slope-intercept form gives us the slope and the intercept. Now slope in shorthand is referred to as m, and the intercept, or the y-intercept in shorthand, is referred to as b. So the form of the equation is going to be y is equal to mx, which just means the slope times the x value, plus b, or plus the y-intercept. So I can write in here that m is equal to the slope, it's shorthand for the slope, and b is equal to the y-intercept. Now I can write the y-intercept either as a value, b, or the coordinate for b. So in this case, I take a look at my equation, y is equal to 3x plus 2, and I see that the slope is simply equal to 3, and the y-intercept is equal to 2. And again, I can write the y-intercept. The first value will be 0. The next value will be the y-intercept of 2. Okay, a function in slope-intercept form just replaces y with f of x. So f of x is just basically the same thing as y, but it just means it's referring to function of x. So if you see f of x in the future, you're going to be able, for the most part, in this type of format, you're going to be able to replace f of x with y.